Okay, so I'm recording this session, but I'm using a different software to record, so you won't basically hear that this session is recorded. So first agenda for today is the grades. Okay, so there are two students who were reaching out to me with regards to the confusion of the grades for the exam number 2. So what you will notice there, there's actually two um, I'm sorry. Let me just add a few more people. Okay, there you go. So this is with regards to the grades for your exam number 2. So what you would notice there's actually two things that are reflected. The first one is your raw score, and the second one is the percentage. Okay, and what you will notice is that those two numbers actually don't match. In fact, your percentage score is actually lower than your raw score. And if you remember, I have embedded some bonus points into that exam. So what Canvas did, that Canvas didn't know that. What Canvas did is that it took your raw score and it divided it by not by 100 points, but rather with 100 points plus the bonus points. That's why you will see your score go down. So don't worry, I'm going to use your raw score and it's going to be out of 100. So let me just share my screen here real quick. It's not going to be the same format as you guys. You probably won't have the same, it doesn't have the same format, but when you go to your grades on Canvas, you're gonna see, right now you see only one. Okay, you're gonna see the percentage that you got from the exam number 2. I'm not gonna use that. I put that in the folder that doesn't bear any weight on your score. What I'm gonna do is I'm going to put your raw score in this folder right here, which will be used to calculate your overall score. Okay, so you're going to see two things. I'm going to do that this afternoon. You're going to see two scores for exam number 2. Unfortunately, I can't erase this because this is where you took your exam. But just know that that doesn't have any bearing or any weight on your calculation. Just like when you're doing your exam 2 practice. Okay, so when you're doing the practice sheet, you will have a score, but even if you perfected it or you have a 0 score, it's not going to bear any weight. Okay, so this folder has 0% weight. Okay, now if you have any more questions with regards to the exam 2 scores, feel free to stay after the class or go to the office hour, which is right after this lecture. Okay, so now we're on our second half of this course. So if this is basketball, we're on our third quarter, and usually this is the time to do self-evaluation. Now, I know in the first 2 quarters, it may not be the performance that you want to do or to achieve, and that's okay, right? So you're still figuring out how the online course works. You're probably thinking or figuring out how this course is working with along with your schedule. But now should be the time to really evaluate what works for you and what didn't work for you. Okay. What I noticed, so because it's a third quarter, please allow me to have this gentle reminder. Okay, so what I noticed is that some students, out of the 50 students, 50 plus students, there's only like 15 students who watch the lecture last Tuesday. Okay, it's the recorded one. If you remember, I post them every Monday, 9 a.m. So you have that time span, Monday, Tuesday, or Wednesday to view it. And it's really expected of you to watch that so that when you come here, we just basically build concepts on top of that. So how can I help you guys if you don't watch it, right? So basically you are shooting yourself in the foot. It's something that you might want to consider now that we're on the second portion of the course. Um, there's still hope, guys. There's 2 more exams. Okay, so just focus on those 2 exams. If you did poorly on the first half, don't worry. Next meeting, since we don't have much time today, next meeting, I'm going to talk about how you can make up those lost points. But what I really want to see here is that you would really, it's game time now, right? So you would see those basketball players, even if they do poorly on the first half, they're still working, right? Yeah, we're going to talk about that extra. It's not really extra credit because you're going to have to work for it, okay? Next meeting. They're still those basketball players, they're still dribbling away, even if you look at their scores, they're already in the losing end. That's because they know there's still a chance for them to get back or retrieve those points. Okay, so it ain't over yet, guys. It ain't over yet. I've seen people with a D bring it up to a B, or even a C bring it up to an A. It's really a classic move of the student. Like really, when push comes to shove, they can really do it, and I really hope that I can see that in you guys as well. All right. So now we move on to our topic for today. This is building on top of what you have watched last Tuesday. If not, I'm going to try to make it easy so that you can still figure out what's going on today and then make up for it. Just make sure that during the weekend you really go back and watch that video. Okay, here on the board, we're gonna see that it's actually a series, a domino effect. You really need to have a solid structure in the first part so that you can move on to these concepts in the following modules. Okay, so what I want you guys to see here on, please kind of look at the list of cameras. You're gonna see there's two names there. I'm using two devices right now. Right now, you're gonna see me on the screen. So there's also another one, and I'm using my phone here as my second device because I would need this so that I can show you some molecules. Okay, so I hope you guys can see the second one, my iPhone. Okay, so you can just toggle it. If you go to that triple dot on the upper right, you can actually right click on it and pin that video so you can actually see it big in a bigger screen. Okay, so this is my second one, so you can pin that and you can see the screen. Hello. Okay, and we can unpin it back. All right, so I've also just sent an announcement just a couple of hours ago for the lecture handouts, just in case you want to take down notes. But you can, if you haven't printed it, that's fine. You can take down notes as we go along. It's actually not that bad. Okay. Alrighty. So what I'm going to show you here, let me just shift my screen here so that I can see it in my phone mode. So what you're going to see here is actually mainly 5 molecules. Okay. And this is a representation, molecular representation of the molecules that we're about to go over. Okay. 1, 2, 3, 4, and 5 and 6, actually 6. Okay. So last Tuesday we talked about how to draw the Lewis structures, how these atoms that are found in the compound are being connected. But now we're going to look at their shape in 3D. Okay, so normally on ground you're gonna see this kit. We provide this to you guys, but since we're not in the lab, so I'm just gonna introduce this or show you guys that this is what you will typically see. You're gonna build models in the lab. So the black, there are different colored spheres. They represent certain atoms. Usually the black ones are your carbon. It contains 4 holes. Then you have your nitrogen, which is your blue sphere, the oxygen, which is your red, sulfur, and the green one are usually the halogen groups. And you can see there's this white sphere, which is, I used a lot of this during when I build the model. That's your hydrogen, the little hydrogen. Okay. And when we're building this, we're using the sticks or our bonds. And you will see that there are two different kinds of sticks here. We have a short stub one and a longer thin one. Okay. So when you're creating single bonds, you usually use this short stubby stick. But when you're creating double bonds or triple bonds, multiple bonds, you're going to use this long one, mainly because it has give. It actually is flexible. So when I'm doing this model, I'm going to start with the Lewis structures. What you see there is that I shared with you some molecules right there. This is the one that we did on Tuesday. And what you're going to see here is that on Tuesday, we basically know how to draw the Lewis structure. So you'll be given HCN, the molecular formula, and you're going to be asked to draw the structure, right? Okay, so say for instance, you know how to draw this, and please refer to last Tuesday's discussion if you don't know it yet. But we're going to start with the first molecule, okay? That's our HCN. So I hope you guys can see this. Can everybody see this, guys? If you can't see this, just go to Zoom. I actually pinned this video so you can actually see it. Can everybody see this? All right. Okay, good. So what you will see here is your hydrogen atom, and then you have the black carbon, and you have your nitrogen. So basically your carbon is connected to hydrogen on the left and nitrogen on the right. And you can see the 3 bonds right there. That's the triple bond, okay? Now, if you're going to have a, a barbecue stick, and imagine trying to skewer this. So you put the hydrogen, carbon, and nitrogen together. It will all be in one stick. And if you look at the side, it would appear that you will only have one atom. So if you go to look at it in this orientation, there's actually more atoms than that. So that shape is actually linear. Okay, so it all goes in one line, and the shape is 180 degrees apart. You can have carbon attached to 2 groups, 2 physical atoms, or just 1 physical atom. Okay, so that makes it linear. Okay, very easy, right? So that's one of the 5 that I'm going to ask you guys to learn today. And we're going to have a Zoom or Kahoot activity. So please try to put this or jot this down in your notes. When you have one, if they all fall in one line, that's what we call as linear shape. Okay, so whenever we're trying to figure out the shape of the molecule, we just look at the central atom. You don't look at anything else, but rather the atom that's in the middle. And then you're going to focus on the number of electron domains or electron groups that is attached to it. When we talk about electron groups, we're talking about the electrons that is from the nearby atom or the lone pair that that central atom will have. Okay, so don't worry about the second category first yet. Just focus on the number of atoms attached to the central atom. It doesn't matter whether it's singly bonded or triply bonded, just count the number of things or atoms attached to it. So 1, 2, so that's linear. Okay, now we move on to the second. Oh, kind of moving a lot, guys, so I hope you guys don't get dizzy from this. Now we move to trigonal planar. Trigonal planar is very easy to spot. So this is your molecule and its Lewis structure. If you look at the central atom, you have your carbon. There are 3 physical atoms attached to it, 2 hydrogen and 1 oxygen. So it's that shape model right there. So we have 3 physical things, 3 electron groups, and it's 120 degrees apart. So just divide 360 by 3, so you have 120. Okay, now why is it called trigonal? Because there are 3 electron groups. Why is it called planar? Because it all lies in the same plane. So if you have a samurai sword and you try to cut the equator, okay, so they all will lie in one plane. Okay, so if I try to go, let me see if I could, okay, you guys can see that. So that's planar. Okay, all right. So 3 electron groups. So we actually increase the number of attachments or number of atoms attached to the central atom by 1. So we started with the 2 groups, that's linear. When there's 3 groups, that's trigonal, planar. Okay, now we'll go with 4 attachments. Oopsie. The classic methane, CH4. Okay, that's your shape right there. We have your carbon, and there are 4 electron groups coming from the 4 hydrogen atoms attached to the carbon. Okay, so the shape is tetrahedral. If you look at the Lewis structure, guys, you might think like, oh, it's a T shape. That's not the case. You are looking at a 2D representation of a 3D molecule. So be very, very careful when you're assessing the shape of the molecule through the Lewis structures. There are 4 things. You might think that there's one on the north, south, east, and west end, but it's actually, the shape is tetrahedral. What I mean by this is that imagine a tripod, and these 3 hydrogen atoms are the legs of the tripod. They're sitting on the ground on the table. Look at your carbon. It's not on the same plane. It's slightly elevated. And then if you look at the 4th hydrogen atom, just imagine your iPhone or your camera sitting on top of your tripod. Okay, so the angle there, if you look all over in between, there's 109.5 or 109 degrees apart. Okay, so tetrahedral. So we started with linear, trigonal, planar, and tetrahedral. So I hope you guys can remember those 3. Okay, in fact, these are the 3 main things, and there's just variations from these 3. Okay, okay. So I see that there's a student who couldn't see um, this video. Jasmine, can you just look at the Zoom and what I shared on the screen? Maybe I'll share my screen right here. Okay. Oh, okay. No, that's okay. Can you see the shared screen? And it's going to be a little bit limited there, right? So, um, let's see. It's kind of difficult too because I'm using a different software too. All right, let me see. If I stop that, you won't be able to see it. Okay. Okay. All right. Now, why don't, yeah, so you have the lecture notes. Okay. So we're actually going in sequence to that. Okay. And then I'm going back to the notes so that you can see it. I'm just going to stop this. I'm just showing the molecules for now. Yeah. Yes. All right. Thank you. All right. So, we have the tripod with the camera on top. Now, what if, imagine removing that camera? So all you will have is the tripod, right? So that's actually now the next molecular shape. So if you look at our ammonia, NH3, you will notice that there's actually 3 hydrogen atoms. And then at the top portion, there's the lone pair, the electrons that are not being shared in the process. Okay, so there's actually, it may appear to have only 3 groups, but there's actually 4 sources of electrons. Okay, or electron domain. Electrons coming from the hydrogen atom, so that's 3. And then the fourth one, that is the electrons that are not being shared. So your ammonia actually will have a generic pattern like your tetrahedral, except that I remove that camera on top of your tripod. Okay, so this little lobe right here is your lone pair. So the angle, because the electrons here is very exposed, it actually has more repulsion or bend and causes these bonds to bend down. Okay, so why do they have this shape to begin with? So remember, these atoms contain electrons. Electrons are electronegative, has negative charge. They repel each other. So imagine when you have the same charge and then you are forced to sit in a certain spot or be in the same proximity, you don't like each other. So you tend to repel, but you have no choice because your nitrogen here is holding you back, right? You can't just wander away. So the atoms, in order to just coincide and live for the betterment and just be happy, they just try to rearrange themselves. They bend the bonds so that there's lesser electron repulsion that these bonds will experience. So they're more stable, and the energy there is less steric hindrance, right? So less stress. All right. So that's what we call, that's what causes these bonds to have a shape. And in fact, if we go to the notes, we're gonna go there. This theory is called VSEPR, or the valence shell electron there is gonna cause some repulsion. So electron pair. Okay, we're gonna get to the notes so that you can see it a little bit later. But that's just some theory or concepts that we can just skip for now. So again, what is the shape? It's no longer tetrahedral, guys. This shape is now going to be on its own. It's going to be called trigonal pyramidal, because this is actually non-existent. This is just a cloud of electrons, okay? So in theory, there's really nothing there. But because it is electrons, it just has those electronegative charge, it pushes the bonds. So it's still trigonal, but then now the shape is pyramidal. Okay, so it looks like a pyramid. So notice that it's not like your trigonal planar where all the atoms are lying on the same plane. You will see your central atom actually a little bit elevated or off the ground. So 4 electron groups, 3 of which are physical atoms, and 1 is a lone pair, okay, or an electron. Okay, so that's your trigonal pyramidal. And these lone pairs, because they're exposed, they have more push on these bonds, and so that's why the angle here is lesser than 109. All right, now we move on to another variation of your tetrahedral, and that's your water, H2O. If you draw the Lewis structure of your water, it would just look like linear because you have 2 hydrogen atoms and 1 oxygen. Okay, again, this is where students often had a mistake, is because they look at the Lewis structure and then they would then analyze and look at and tell me that the shape is linear. Notice that there are actually 4 groups, electron groups or electron sources in here. You have the 2 physical atoms from the hydrogen and the 2 lone pairs, 4 electrons that are not being shared. These electrons can push the bonds so that it will bend your bonds. Okay, so this is a bent shape. So here I'm not putting the lone pairs, but just there's an imaginary cloud of electrons here that's hovering above this oxygen molecule or water molecule. Okay, it's pushing these bonds down. So the shape here is now bent. So how many things are electron groups? So that's always the thing that you're going to look at. You don't look at the Lewis structure, but you look at the central atom and the number of electron groups. How many electron groups are there? 4. 2 from the hydrogen, 2 hydrogen atoms, and 2 from the 2 lone pairs. So because they're not all physical atoms, there's two lone pairs and two bonding pair. You just imagine your tetrahedral, remove the camera, remove one of the legs, and what do you get is a bent shape. Okay, so that's how you can figure out whether it's a bent shape. Okay, so far we talked about 5. So technically there's 3, but then the other 2 are just variations. So now you have 5 different shapes. Now let's go back to our trigonal planar a little bit, okay? Remove one of these bonds. And what shape do you think closely resembles to the one that we have talked about? What shape do you think is this? This is not linear. Very good. Bent shape. Okay? So your trigonal bonds, which has 3 electron groups, if one of them is not a physical atom but rather a lone pair, you can also have a bent shape. So this is the last one, GEF2. If you like the Lewis structure, so here we have the model. Instead of having a third domain, a physical atom, we replace it with a lone pair. Okay, so that will be bent shape. The angle is still roughly around 120, but like we said, this electron from this lone pair actually is exposed, so it can really bend these bonds further, and that's why the angle here is less than 120. Okay, so let's go now to our notes. I'm gonna slightly close this video device. I'm now gonna go to my notes. So if you go to the first page, what you will see there is actually this graph. Okay? Feel free to print this out so that you'll have some reference for your exam. If you notice, it's being arranged according to the number of electron groups attached to the central atom. We only focus on the central atom, okay? And the number of electron groups, may it be an atom, a physical atom, or a lone pair. So notice that there's quite a lot of shapes actually. And if you proceed to Chem 400, you're going to visit this again. But what we're going to focus is just this first 3: linear, trigonal planar, and tetrahedral. And then you're going to see the variations. If you remove one of the atom and replace it with a lone pair, the shape becomes bent. Okay. For tetrahedral, if you remove the camera, the shape is trigonal pyramidal. If you remove one of the legs of the tripod, you're going to get a bent shape. Okay. So there's just 1, 2, 3, 4, 5. 5 different shapes that you will get from what we discussed. Any questions so far, guys? Is this a little bit clear? Notice that we're not really doing a lot of calculations. In fact, for the third exam, it's not calculation heavy or math heavy. It's really going to be you make use of your analysis or spatial orientation. It's going to use a different portion of your brain. I hope you guys can recover from this third exam. Okay, so on that note, let me just test whether you guys fully understand here. We're gonna open our Kahoot game, so please turn on your other device, plug in kahoot.com, and let's try to play a game. So ID number 8258680. Let me just type that down. Eight two five 8680. 0. Okay, I'm going to show you different structures, and you're going to tell me the shape um, of those compounds or species. Screen isn't shared. Hold on. So how do we assess our shape, guys? We focus on the central atom and count the number of electron groups attached to it. So electron sources could be a nearby atom. It doesn't matter whether it's singly bonded or doubly bonded or triple bonded, and count the number of lone pairs. Alrighty. And of course, I'm going to grade this, guys. So if you have just your participation, okay? If you don't know, if you're still struggling, there's an option there that says, I don't know. The, yes, so 825-8680. Okay. Yeah, no worries. So phone not loading. Okay. So what you could do is you put your answers on a piece of paper, take a picture, and then send it to me. Okay. All right. So like I said, guys, it's just more of participation. If you go into Kahoot, um, if you don't know the answer, there's an option set that says, I don't know. Okay. But as much as possible, let's try to check our skills. Okay, Jasmine's in. All righty. So go and review. So I'm just going to open this screen one more time. Again, we're just going to focus on this first 3 rows. If you don't like this, guys, because it does looks a little bit confusing with the E and the X here, and it's possible too during the exam that I would give you a hypothetical structure. Okay, so with just some random letters X, Y, and I'm gonna draw it out. You need to know how to project those shapes. Okay, so something that you cannot Google. So please know it. If you're not comfortable with this, by all means, make your own. Okay, and refer to that. All right, let's get started. Is everybody in? I have 40 people in. Okay. Let's try this shape. CH3Cl. Okay. We have one that says it's trigonal pyramidal. No. Focus on the central atom. We have carbon. How many things are attached to carbon? 4. There are 4 physical atoms, 3 hydrogen atoms, and 1 chlorine. So 4 things is like a tripod with a camera on top. That's tetrahedral. Okay. Now, these examples here, how to draw the Lewis structures, they're actually taken from our lecture from last meeting. So if you want to know how I draw this, please refer to that lecture. Alrighty. So hopefully as we go along these 5 problem sets, there's lesser and lesser people who have an error. Okay. How about this molecule? BF3, boron trifluoride. Oh, it's split between trigonal planar and trigonal pyramidal. Okay. All right. You guys are on the right track. At least you have the trigonal part correct. There are 3 things attached to your boron. Okay. All of them are physical atoms. Okay. So that's trigonal planar. They're going to orient themselves spatially or equally. So imagine boron carrying triplets. Okay. So it's going to try to pull in different directions. So it's going to shape itself in more symmetric as possible. Okay. To avoid that steric um, or repulsion. So that's 120 degrees apart. That's trigonal planar, guys. Trigonal planar. Okay. Remember, trigonal pyramidal can only occur when you have a big electron cloud that's pushing the bonds down, making it like a tripod. Oh no, I pressed the right answers twice. Time's up. Okay. All right, let's try to do it. Okay. What is the shape of this molecule? All right, we got majority of you guys got it right. Awesome. It is linear around carbon. There are 2 oxygen atoms. So remember the barbecue stick that's skewering these atoms, they all will lie in the same stick. So that's linear, all lying in the same plane, 180 degrees apart. It is not bent. Okay, you can't bend it down. Okay, so it all lies on one line. Okay. And I think we have 2 more, guys. So don't look at the multiple bonds, because sometimes you will look at multiple bonds and count them twice. No, you just count the number of atoms near your central atom. It doesn't matter, again, whether it's multiple bonds or single bond. Absolutely. For those who missed it because of internet connection, this is actually posted after the lecture, so feel free to work on this exercise again. All right. Phosphorus tribromide. trigonal pyramidal. Yes, so I see a confusion there between tetrahedral. Um, it came from tetrahedral. Yes, you guys are correct. But imagine your camera as a non-existent atom. So there's no physical atom in there. It's actually just a cloud of electrons. So all you have is the tripod. So that's just trigonal pyramidal. Okay. Okay. And lastly, molecular shape of this ion, cyanide. Linear. Very good. It cannot bend down. You have carbon and nitrogen. There's carbon, two atoms actually. If you try to put a barbecue stick, you can't have a dangling nitrogen down, right? Carbon and nitrogen is gonna go on one line. Okay. I always associate it with barbecue stick because I like to skewer meat. You can't have a dangling carbon, right? So it's all will be skewered in one stick. So it's gonna be linear. Alrighty, guys. So that ends our Kahoot game. All right, so pretty much the exam is like that. So if I'm going to test you on the shape, you should know how to draw the Lewis structure, of course. If you missed on the Lewis structure, what can we say, right? So if you miss on the Lewis structure, it's going to be like uh, a domino effect. So Lewis structure is a very important concept for you guys to know. Once you have that, then you'll be able to know how to predict the shape of the molecule. Okay. All right. So again, how do we, let's review. Okay. Three things. Focus on these three main shapes. Whoopsie. Just focus on the number of things attached to around your atom. 2 groups is linear. 3 groups is trigonal planar. 4 groups is tetrahedral. If you take out the atom and replace it with a lone pair, that's when you have the variation. So a trigonal planar, if you remove the shape, that's bent shape, right? Tetrahedral, if we remove the camera, that's trigonal pyramidal. Notice how carbon is elevated like a ghost, right? Take out another and replace it with another lone pair. What shape is that? That's bent. Okay, bent shape. Alrighty. So now that we know the shapes, let's move on to the next step, and that's figuring out the polarity. Okay, bond polarity. Oh, well, actually, we're not yet there. So those examples that I gave you are really simple structures. There's only one central atom that is found, but what if you have a complex molecule? Okay, when you have a complex molecule, you just have to focus on the central atom. Okay, let's try to take a look at this guy. So we have your acetic acid, CH3COOH. We discussed how to draw the Lewis structures of a very complex structure last meeting. So please go back to that. So when you have organic molecules, it's safe to use the shortcut method. Okay, so when you have carbon, it usually will have 4 bonds and no lone pairs. When you have nitrogen, there's 3 bonds and one of it is four groups, total of octet. 3 of those are bonded to an atom, while the one is bonded to, is just a lone pair. Oxygen is 2 bonds and 2 lone pairs. When you have a halogen group, group 7A, like chlorine, bromine, fluorine, you're only singly bonded, and the other electrons there are lone pair electrons. They're not bonded or shared with other atoms. Okay, so here's our acetic acid. When we're asked to know how the shape of this complex molecule, just focus on the central atoms. How many central atoms do we have? Okay, we know it's a central atom because there are other atoms attached to it. We know it's a terminal atom because it's dangling out of the terminal atom, of the central atom. So here, that's our central atom. This is our central atom. And this is also a central atom. This hydrogen is not a central atom, it's a terminal atom, and so we don't consider that. Okay, so there are actually 3 central atoms, carbon 1, carbon 2, and the third one is not carbon, it's oxygen. So around carbon 1, just focus on the nearby atoms attached to it. How many things are attached? We have 4. 1, 2, 3, and this rest of the structure. Because there are 4 things, electron domains, all 4 of them are atoms, the shape around central atom 1 should be, can someone take a guess? Very good. Tetrahedral. Okay, so don't get scared by the complexity of the structure. Just focus on your central atom and look at the neighboring atoms attached to it. There are 4. That means it will give you the shape of a tetrahedral shape or geometry. Now let's take a look at a central atom number 2. That's your second carbon. What are the nearby atoms attached to it? So we have our oxygen. We have this thing right here on the right, this thing right here on the left. 3 physical atoms. And so the shape would be, someone is, just shout it out. I know you guys are chatting. It's hard for me to go and look at the chat. Okay, let me see. Trigonal planar, very good. I was kind of scared there to begin with because you gave me 3 answers, but I see what you're just doing there. You're doing for each central atom. Yeah, so this one is trigonal planar. All right, now let's take a look at the next one. Oopsie. Okay, the third central atom, your oxygen. Around oxygen, there are 2 physical atoms or 2 physical things attached to it. And then there's 2 lone pairs, a total of 4. So think of the tetrahedral, remove the camera, remove one of the legs, the shape is going to be bent. Okay. All right. Now, there's also cases where I would give you a partial Lewis structure. You would need to complete it first and then figure out the shape of each of the, around each of the central atoms, okay? So just remember this shortcut method because usually this is for organic. Most organic molecules would follow the octet. They usually don't have expanded structures. Most of them also will have typical sharing of electrons. So it's not a coordinate covalent bond. And so we're going to use this shortcut method, okay, to assess and complete the Lewis structures. If you've already had this, so kindly complete this structure. And let's go over and figure out the shape of around each of the central atoms. So write it out on your notebook first. Let me just go up here and grab this thing. Oops, I can't do that. Alrighty. Now, I do want to caution you guys if you're going to use the shortcut method in assessing all of the structures, okay? Remember, this only holds true for organic structures. You have my blessing to use the shortcut method, but for other compounds or other species, you need to do the long method of how to draw the Lewis structures. Meaning to say you have to account for all the valence electrons, and then you have to do that whole long process, okay? Because it's possible that the atoms there, or the central atom is expanding, so it can have more than 8 electrons around it, okay? It's also possible that that atom is not sharing the typical nature, but rather is a covalent coordinate bond. Alrighty. So what is missing around? Let me just highlight the central atoms first. Okay, so we have this carbon. This oxygen can't be a central atom because there's nothing attached to it. So it's a terminal atom. And then we have this. So we have 4 central atoms. Let me just label this as 1, 2, 3, and 4. What is missing around carbon 1? Feel free to just shout out instead of text in the chat box. Where? Around the second carbon? Correct. So we can't, it's missing. So remember, carbon needs to have 4 bonds. Here we only see 1, 2, 3. That means it's missing a bond. We can't have the double bond around hydrogen because hydrogen only requires 1 bond to be stable. It only needs a duet. So double bond has to be between carbon 1 and carbon 2. Okay, so around this central atom, it's already has achieved octet. Now, if we take a look at carbon 2, there are already 4 bonds, so now it's correct. If we take a look at carbon 3, it's missing a bond. So I'm going to put the bond on top. Okay, I can't put it to the left because if I do that, then this carbon for that will have 5, right? So here I'm going to put the double bond on oxygen. And so now carbon 3 is happy. But if I look at oxygen, what's missing is that 2 lone pairs, a total of 8 electrons, right? Then if you look at nitrogen, around nitrogen you have 3 bonds and you would need the missing lone pair added in, okay? So if you know how to complete the Lewis structure, I'm going to give you points for that. So now we are going to do the assessing of the shape. Okay, so we have 4 central atoms, so we're going to look at each of these central atoms. Around carbon 1, the shape will be how many things are attached to your carbon? So we have trigonoplanar. Okay, let's see. We have 1, 2, and this entire thing, okay, docked and attached or glued into carbon 1. So that's 3 things. It's trigonal planar. All of those are physical atoms, so that's trigonal planar. Let's take a look around carbon 2. We have this on the left, this on the right, and we have that hydrogen, so that's also trigonal planar. Around carbon 3, we have the oxygen, and the one on the left and the one on the right. Okay, so that's also trigonal planar. And around nitrogen, what would be the shape? Bent. Good. How is it bent? Focus on the central atom around nitrogen, and then the number of groups attached. So we have 1, 2, 3, 4. Think of tetrahedral. Remove one of the atoms there, the camera. So the shape is just trigonal pyramidal. Okay, so it's just a tripod. Sometimes in a hurry, a student would just give me tripod. Let's try to make it technical. So it should be trigonal pyramidal. Okay. All right. So now if you look at the structure here, this was the molecule that we talked about. So if we take a look at the first one, you might be tempted to say there are 3 things attached to it. So it's just trigonal planar. Oh, sorry. It looks like tetrahedral because there's 4 bonds. But if we close this and create a double bond, you will notice that it's very clear that it's trigonal planar. Okay, we focus around the first carbon. If we focus around the second carbon, that's trigonal planar. If we look at the third carbon, that's trigonal planar as well. And if we look at the fourth central atom, your nitrogen, it's pyramidal. So this is your molecule. Okay, so you will be given a molecule and you will be asked to identify the molecular shape around a specific atom. You should be able to do that in the exam. All right, let's try to complete the Lewis structure here with a few more guys before we take a break. So let's try to complete the Lewis structure of this. Oh, okay, I'm missing a few more. Sorry. Sorry, I forgot. Okay, so say for instance, I'm gonna give you this Lewis structures, and then I would say this is incomplete. Kindly complete the Lewis structure. You should be able to do so. Just go with the shortcut method for organic structures, and what you would be missing there would be the lone pairs around the oxygen. Okay, and you should be able to do the assessment. Okay. Now, when molecules are really complex, sometimes when molecules are very complex, sometimes it's too tiring to draw the molecule and the number of atoms. So we usually have this condensed way of drawing the structures. Every line, if you look at some examples there, we're going to see lines represented. We're going to show the bonds between the 2 atoms. Every ends and corners there called vertices, there's a hidden hydrogen on it. Okay, so here we have a carbon, sorry, not hydrogen, but rather carbon. For organic structures, we usually have carbon as our backbone. Oh my gosh, just carbon as our backbone. So we can draw it back. Okay, so let's do a simple one for now. Let's try to do just this. Okay, so this is the condensed way of writing a molecule. If I could ask you to draw the Lewis structure of this, just know that each of these vertices or ends are hidden carbons. So you could draw it back. Now remember, carbon needs to have 4 bonds. So there's also, it implies that the remaining 3 here that are not shown are bonded to hydrogen. For organic structures, it's usually made up of carbons and hydrogens. Okay, so here it implies that there are hidden hydrogen atoms in here. So around carbon 2, 2 of the bonds are already shown. That implies that the other 2 here are the hidden hydrogen atoms. Around carbon 3, there's 1 bond shown. That means there should be 3 hidden hydrogen atoms as well. Okay, so let's practice our condensed structure in these molecules right here. There's 2 molecules, okay? I want you to draw the Lewis structure for these condensed structures. Okay, so let's count the number of vertices or the ends. So we have 1, 2, 3, 4, 5, 6. It implies that there are 6 carbons that are stringed together in a shape of a ring. So we have carbon, 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 carbon. There you go. Don't forget that there's like 2 bonds here, which implies that it's doubly bonded, okay? So just to make it easy reference for us, I'm going to number each of these carbons so that you don't get confused. All right. So now we have just redrawn the carbon that are hidden. So now we complete the Lewis structure. Remember, carbons need to have 4 bonds. Around carbon 1, 3 are already shown. That implies that there's a hidden hydrogen in here somewhere. Around carbon 2, 1, 2, 3 of the bonds are already shown. This implies that there's also another hidden hydrogen. Okay? All right. Around carbon 3, you'll see 2 bonds. That implies that you have 2 hydrogen atoms attached to carbon 3. Now you focus on 1 carbon or 1 central atom at a time. There are 2 bonds here, implying that there's 2 hidden hydrogen atoms. Around carbon 5, 2 bonds are shown, which implies that there are 2 hidden hydrogen atoms, add up to 4 bonds or 8 electrons or an octet around your atom. Lastly, we have carbon 6. There's 2 bonds there. So that means you have the 3rd, 4th bond bonded to 2 hydrogen atoms. Okay, so this is the Lewis structure of your molecule. Now, if you look at a molecule as complicated as this, don't you appreciate writing it in a condensed way, right? Rather than looking at this really weird molecule or very complex molecule, it's much neater if you look at it in a condensed structure. But now the final end question is, I might ask you during the test to give me the shape around carbon 5. Okay, so you have to draw around carbon 5. Focus that there are 2 bonds here, implying that there are 2 hidden hydrogen atoms. Therefore, the shape around carbon 5 must be tetrahedral. Does that make sense? If you just look at the molecule and you look at this, there's 2 bonds and it's bending down. It looks like it's a bent shape. So be very, very careful. There are hidden hydrogens in there. You're around carbon 5, there's actually 4 electron groups. So that takes the shape of tetrahedral. Okay, so we'll take a little 10-minute break here, guys. I want you to draw the Lewis structure of this condensed structure right here. Okay, and then to identify the central atoms and then the shape. Okay, so let's take a little break and 10 minutes. We'll resume our class at 1:15.